So for this video, we're going to be looking at some more graphing examples, but here we'll see that it's still in standard form, but it looks just a little bit different. We're missing some terms. So for number 1 here, I have that f of x is equal to 2x squared minus 5. I can make this into standard form by just adding a 0x in there, because I realize I'm missing my x term, so I'm just going to add in a 0x. And now I can go ahead and do this just like I did in those previous examples. So I want to start with finding my axis of symmetry. So x is equal to the opposite of b over 2a. Well, my b term here is just 0, so I have 0 over 2 times 2. So I have that x is just equal to 0. Since x equals 0, that is just my y-axis. I'm not going to go ahead and graph that axis symmetry because there's already a line there for us. And then to find my vertex, I need to plug in 0 to figure out what my y value is. And so I have that y is equal to 2 times 0 squared minus 5. So y is equal to negative 5. So that means my vertex is equal to 0, comma, negative 5. Now this one it's a little bit different because my vertex is actually also my y-intercept. So I can't actually reflect this point to find another point. So in this case, I'm going to have to plug in some other values into my function to figure out what these other points are going to be. So what I'm going to do is I'm just going to make a little chart here. And so I'm going to go ahead and just do 1 point on the left of this, so at negative 1. And then we already have the one at 0. 0 is negative 5. But then I'm going to also just do 1 on the right. So to figure out what y is equal to when x is equal to negative 1, I need to plug in negative 1 into my function here. So I have 2 times negative 1 squared minus 5. Negative 1 squared gives me a positive 1 because negative 1 times negative 1 is 1. So I really have 2 minus 5. And when I subtract those, I get negative 3. And I'll do the same thing with 1. So I have 2 times 1 squared minus 5. So 1 squared, I get 1. 2 times 1 is 2. 2 minus 5, I also get negative 3. So applying those points, I have the point negative 1 comma 3. So left 1, down 3. And then right 1, down 3. And so I get this as my parabola. Domain, again, that's just going to be all real numbers. And then the range, since this is opening up, is going to be y is greater than or equal to, and it's just going to be greater than or equal to whatever my y value is in my vertex, which here is negative 5. Now for this last one we have f of x is equal to negative 1/2 x squared. So here I'm actually missing all of my terms to the right, so I can really just add a 0x plus 0. So now whenever my b term is 0, just like we saw here, x is going to equal to 0 as well. And so to find what my y value is, I can go ahead and plug in 0 for x. So I have negative 1/2 times 0 squared. And so y is going to equal to 0 as well. So that means my vertex here is just going to be 0, comma 0. So I won't have to do the same thing here like I did on my previous problem. And so I can pick any points to the left and right of 0. I'm going to go ahead and do, just so we have some further out points, I'm going to do negative 6 and then positive 6. It doesn't matter which ones you do. You could do negative 1 and 1 or anything like that. But I would recommend doing the same number because you do end up with the same thing at the end. Just like we had negative 3s here, we should end up with the same number here as well. So plugging in -6. Let's not go with negative. That's going to be too big. Let's go with 4. So plugging in -4, I have -1/2 times 4 squared. Well, 4 squared, that's just 16. 16 times -1/2, I get -8. And now -1/2 times 4 squared will get me -8 as well. And so that gives me the points -4, -8, and then 4, -8. And then I draw my curve. Domain is always all real numbers. And then range for this one, since the graph is opening down, it's going to be y is less than or equal to, and then my y value in the vertex is 0.